Hey everybody, it's Mr. Carr again. Today we're going to be talking about 5B. We're going to solve systems of equations, but we're going to do it with a process called substitution. Graphing equations is a nice way of being able to see the solution. You see why we call it that. It's when the two lines are crossing each other. Okay. Here with substitution, it's a little bit easier to do because sometimes when you graph lines, you're not going to be able to see the exact point that they cross. Okay. Sometimes it's going to be a little bit harder. So give me just 1 second here. Okay. And we're back. All right. So yeah, today we're going to be talking about substitution because sometimes graphing is not as effective as, I don't want to say effective, but sometimes it's a little difficult to see the exact point that the two lines cross. So that's what we're going to focus on today is another method. So here are the steps. Okay, so step one, when necessary, solve one equation for one variable. Okay, then, so for example, it would look something like this. You could say x equals 2y plus 4. That's when an equation is solved for a variable. And you might solve for x, you might solve for y, it just depends on what you're given. Step two, substitute the resulting expression from step one into the other equation. Oops. To replace the variable. So for example, let's say that this is my one equation, and then let's give me another one. I don't know. Let's say 2y plus 3x equals 17. The idea is that I now have 2y plus 4 can replace the x. So that's going to go in here. So it would look something like this. 2y plus 3 times 2y plus 4 equals 17. Okay, then solve the equation. So that'd be my goal here. I now have turned two equations with two variables into one equation that only has y in it. So that's the goal, is to get that into one variable so then I can go through and solve it through our normal solving steps. So I can distribute and so on. Once I get to a y value there, I would substitute the value from this step into either equation. Okay, and I would want to go back to one of the original ones, and then I could solve for the other variable. Okay, so I don't know. Let's see here. That'd be 6y, that'd be 8y, that's 12. I get a fraction here. Okay, so y is going to end up being a fraction, but the idea is that y is going to equal to some kind of a number. That means I can take that value and plug it in here. So now I have x equal to something. I could solve for that, or I plug it into this one. Sorry, this one right here. So I could take that y value, plug it here, and I could solve for that x. It's whatever, honestly, it's whatever easier, but just make sure I always plug it into the original equations. When we get our answer from that, we get an x value and a y value. You always write your answer, unless it's a word problem, you always write the solution as an ordered pair. Remember, we're representing when the two lines cross. So that's what we want to show. We want to show it as an ordered pair. So a couple examples we'll go over on that one. So we're going to do this through substitution. In the first case, we're already solved for y. It's already nice and easy. So if y equals negative 4x plus 12, and this is the same exact y value in the other, because remember, they cross, the x and the y values are going to be the same values. So that means I can rewrite the second equation like this. 2x plus, I put parentheses there just to show this is the original y value that it's being swapped out. From there, I now have just one equation with x in it and no y. So I can do 2x minus 4x is going to give me a negative 2x plus 12 equals 2. And then I can subtract 12 to both sides, so that negative 2x is equal to a negative 10. Divide by a negative 2, and I get x equals 5. From there, I need to find the y value. So I'm going to take that x equals 5 value. And you know what? I'm running out of space. Whoa, hello. Didn't want that. That was fun. So I'm going to actually just scoot that over there. Magic of technology there. So for my next step, I'm going to take my x value. I'm going to plug it into either one of them. I think the first equation will be easier, but it doesn't matter. In fact, I'll do both just so you can see. So negative 4 times 5 plus 12. So y is equal to a negative 20 plus 12. Y equals a negative 8. Okay. If I did the second equation, 2x, 2 times 5 plus y equals 2. 10 plus y equals 2. Subtract 10 over, and y equals a negative 8. Doesn't matter. Final step. Write it as an ordered pair. Okay. Unless it's a word problem, please write it as an ordered pair. It's a point on the graph that the two lines crossing, and you just show that. All right, let's take a look at the next one. In the next one, I don't have one of the variables solved. So I'm going to pick an easy one. I think the first equation, I'm going to solve this for x. I'm going to do that by adding 2y to both sides. So that x equals a positive 2y minus 3. Okay, oh, I might be blocking that. So let's right there. So x equals a positive 2y minus 3. From there, this x is going to match up to that x, so I could swap that out. So that's going to look like this. 3, and I'll do parentheses, 2y minus 3 plus 5y equals 24. Now I have one equation with just one variable, so I can solve this by my normal methods. I'll distribute the 3 to get 6y minus 18 plus 5y equals 24. 6y and 5y go together as 11y minus 18 equals 24. Add 18 to both sides. So 11y is equal to, is that, okay, that's 42. Interesting. So here's where those cases where graphing would have been tough because I have a fraction for my y value here. Okay. So I'll just make sure. Oh, I made a mistake. Hello. Never mind. 3 times 3 is going to give me 9. So I should have been a 6y minus 9. So that changes a whole lot of stuff. Sorry about that. Okay, so that's a 9 there, which means I'm adding 9 to both sides, making this a 33. Okay, no fractions yet. Because then I do 33 divided by 11, and I get y equal to 3. All right. Now I have the y value, I can plug it back into one of the other equations. So I'll go to the first equation again. So x minus 2 times 3 equals a negative 3. X minus 6 equals a negative 3. Add 6 over, so that x equals 3. Okay, and last step, let's write that as an ordered pair, 3, 3. So that's it for substitution, okay? Here we can do a word problem based on this. So we're going to model model this as two equations basically, and then we're going to be able to do substitution to solve it. A nature center charges $35.25 for a single admission. Last week, it sold a combined total of 50 yearly memberships and single admissions for a total of $660.50. How many memberships were sold and how many single admissions were sold? Okay, so here's where it's getting a little bit tricky. We've got to write our equations. First thing I want to do, let's pick variables. So I'll call that step 1 here. Let's pick some variables. The variables need to answer the question. How many memberships were sold? So memberships, and how many single admissions were sold? So I'll call it M for memberships, A for admissions. Why not? So M and A. Write your equation. So that's my step 2 now. I'm going to model this scenario. So once I've picked the variables, M for number of memberships and A for single admissions, I'm going to look for 2 things I can model. So let's look at this again. So we look at there's certain prices that are being charged. Last week, it sold a combined total of 50 yearly memberships and single admissions. That should look like this. Whoa, hello. Yearly admissions added to the single admissions. So yearly memberships plus the single admissions will equal 50. There it is. The total is $660.50. That is going to be based on the money that's being charged for everything. So if we look at the yearly memberships, that is going to be charged $35.25 per membership. This is how I represent the cost that was raised just from yearly memberships. $35.25 M. Okay. And $6.25 times A will equal to $660.50. Now we have our 2 equations with 2 variables. If I want to solve this through substitution, first thing I'm going to do is I'm going to solve one of my equations for a variable. make it easy. Okay, that was $6.25. So for example, I'm going to take this one. I'll just make that A equal to 50 minus M. So that means I'm going to swap out these two A's here. So 35.25M plus $6.25 times 50 minus M is equal to 660.5. All right. So we'll distribute the 625 through. So 35.25M. That's $6.25 times the 50 is going to give me 312.50 minus 6.25M. Combine our like terms here. So we got 35.25 minus 6.25 is going to give me 29M plus 312.50. So now I can subtract my 312 over. So 29M is equal to 660.50 minus 312.50 is going to give me 348. And finally, let's divide 29 to both sides. Okay, so I do that and I get an M value of 12. But my solution's not solved yet because I got to find the A value. So I'm going to do 12 plus A equal to 50. I'll plug it into the first equation. And I can subtract 12 to both sides. So that A is equal to 38. So I need to answer the question. Okay. I should have done this too. I model in step 2. I solve for step 3. Step 4 is to actually answer it in context. So my fourth and final step is to say this. The Nature Center sold 12 yearly memberships and 38 single admissions. Okay, notice that my final answer has the context. M is 12 yearly memberships. A is 38 single admissions. Okay, so we are answering the question in the context. So we don't want to do an order pair here. I'm not going to say 12, 38. I'm going to state it's 12 yearly admissions and 38 single admissions. All right, so substitution, that's how we solve it. So that's it for this one. Again, this one was a lot easier to do a substitution than trying to graph it. Got one more method we'll talk about in the next lesson. After that, we'll do some more application problems, and that is it for systems. All right. Take care, everybody.